Introducing Phillips Additive Hybrid, powered by Haas, a moderately priced line of additive hybrid machines bringing new capabilities to a wide range of industries and applications. Phillips Corporation, a global manufacturing solutions leader, has taken the innovative laser metal deposition technology of Meltio and integrated it with the world-renowned CNC manufacturing technology of Haas, delivering the best value additive hybrid machines to the market. Combining the high precision of multiple lasers in a compact printhead with metal wire produces high-density parts with good resolution, fast deposition rates, and a clean working environment. The result is 3 machines in one, in a small footprint with full axis travels and all the machining capabilities of Haas CNC. 3D print a large range of materials such as steel alloys, end canal, titanium, aluminum, and copper. Or combine additive and subtractive processes with a one-time part setup, print to near net shape, and machine to final finish. Ideally suited for repair or part modification. If a surface erodes or important features wear, simply add material to build to original geometry. For new product development, go rapidly from design to prototype. Open new revenue streams by producing intricate parts cost-effectively and by being able to combine different materials in a single part. Phillips additive hybrid machines are available on Haas toolroom mills, vertical mills, and universal machining centers, such as the 5-axis UMC 1000 model shown here. Laser power packages are available from 1200 to 3000 watt. This large variety of available machine models and laser power packages allows us to match the best hybrid machine solution for your parts and material requirements. At Phillips, we're invested in your success. Our application engineering and service teams will work with you from initial parts review to machine and option selection, through installation, training, and ongoing after-sales support. Add, subtract, repeat. Maximize your manufacturing potential with the Phillips Additive Hybrid.